Hello, and welcome to my series called The Basics of Trigonometry. I'm just trying to get a basic understanding of trigonometry into your brain. So let's just get started with it. So let's start off. What is a right angle? A right angle is a 90-degree angle. An angle that is 90 degrees. There are 4 right angles in a square. And in a right triangle, there's 1. Right angles are denoted by a small square in the corner of the right angle. Next, we shall move on to the Pythagorean Theorem. The Pythagorean Theorem is very useful in solving the lengths of sides of right triangles, but it only works with right triangles. So don't try to use the Pythagorean Theorem on anything that isn't a right triangle with the right angle in the corner. So say we have a triangle with 3 and 4. This side is length 3, this side is length 4 units, okay? So we don't know what this third side is. This is the hypotenuse of the triangle, and we need to figure out what that third side is. So we can use the Pythagorean Theorem to do that. The Pythagorean Theorem is a squared plus b squared, a squared plus b squared equals c squared. So if we mark this as a, this is b, and this is c, we can find that 3 squared plus 4 squared equals c squared. This is c. Yeah? So if we just go even farther, that's 9 plus 16 equals c squared, 25 equals c squared. And then if we take the square root of both sides, we find that c equals 5. So this would be 5 units, equals 5 units. And that's the basic Pythagorean theorem for you. It will work with any number. Some triangles won't be as nice as this one, the 3, 4, 5. Like, you'll get decimals, you'll get strange numbers. But that's the Pythagorean theorem. And you can use it to find any side. So like, if we use the same triangle again, but we're given the 5 and the 3, then we get, can you still see that? Yeah. Then we would start with 5 squared equals b squared plus 3 squared, and then we get 25 equals b squared plus 9, and then we'd subtract 9 from both sides, and we'd get 16 equals b squared, and you could do the exact same thing, just find b, which equals 4, So that's the Pythagorean theorem. In the realm of right triangles, there are 2 special right triangles that are easier to solve than most because the angles within them are nice and they're great. So the first one is a 30, 60, 90 right triangle, and that means one of the angles is a 30, one of the angles is a 90, and one of the angles is a 60. So this is 30, 60, 90. And then the other type of right triangle is a 45, 45, 45, 90, which would have 2 45-degree angles and a 90-degree angle. For the 30, 60, 90 right triangle, the hypotenuse, which is c, which is always the longest side, is always twice as long as the shortest side, which in this case would be b. So the length of c equals to b for the 30, 60, 90. And we know that b is the shortest because it is opposite the smallest angle. So 30 and b and 60 and a, those are all opposites. 30 is smaller than 60, so b is the smallest side. For this triangle as well, the medium side, which is the leg of the triangle that isn't the shortest side or the hypotenuse, is always, the length of that is always equal to square root 3 times the shortest side. So the length of side A would be square root 3 times b. And that's the 30, 60, 90 right triangle. Just know that and you will be good. For the 45, 45, 90 right triangle, side A and side B are always equal because these angles are equal, so these sides are equal. So side A will always equal B. And then the hypotenuse will always be square root 2 times either of the sides to get the length of that. So say side A is equal to 3, then side B would also be equal to 3, and side C would be square root 2 times 3. Yes. Next, we are going to jump into the basics of angles. So, we have a horizontal line and a random angle coming up from it. We don't know what this angle is, but it exists. So we're going to mark it as theta, because theta is usually what they put down to mark that an angle exists. We do not know the numeric amount to that angle is, but we can use theta as a variable to hold its place. So this is our x-axis down here, okay? This horizontal line. And this is also known as the initial side. This is where all angles start. So, like this angle to be created would have to go up from the initial side to this section, which is known as the terminal side. The initial side is where the angle starts. It's always the x-axis, and the terminal side is the side that is actually the angle. The line that creates the angle. And an angle in standard position will always go from the x-axis counterclockwise to create an angle. So this angle would be in standard position. Looking at these two coordinate planes here, these normal ones, this is a positive angle and this is a negative angle, because this one goes from the initial side to the terminal side in a counterclockwise rotation. If it goes counterclockwise, then it's positive. If it goes clockwise, then it's negative. This one goes counterclockwise this way and is 135 degrees, and this one goes clockwise the other way and is negative 225 degrees. They're the same angle, but this one is positive and this one is negative. This is another example of positive and negative angles. Positive angles go counterclockwise from the x-axis, and negative angles go clockwise from the x-axis. So, jumping into our next topic, the rectangular coordinate system. Most people know this system. It is the rectangular coordinates that everyone uses. So, for the point like 3, 2, for example, you go 3 to the left and then 2 up. It's the same x and y that you've learned since 3rd grade. This rectangular coordinate system has 4 quadrants: quadrant 1, 2, 3, and 4. Quadrant 1, the x and y are both positive. Quadrant 2, the x is negative and the y is positive. Quadrant 3, both the x and the y are negative. And quadrant 4, the x is positive and the y is negative. Moving on, we have parabolas and circles. Now, you don't really, you do need to know this for pre-calculus, but we'll go more in depth with it later in these videos. So parabolas, the basic parent function is just x squared, and they look like this. And you graph them with the equation y equals a times x minus h squared plus k, where a is the amplitude, so how much it's stretched or widened. H is the horizontal shift, so if it goes left or to the right, and k is the vertical shift, so if it goes up or down. So if it's if the k was 1, then the whole parabola would be moved up 1, kind of deal. Circles are a whole different thing. The equation is x squared plus y squared equals r squared, and r is the radius of the circle. So there's no good way to explain this, really. It just, this equation will make a circle, and say the center of the circle here, and the radius was 3, that would make this 3. You know what I mean? The radius of the circle is r. Moving on to the distance formula. It is used to find the distance between 2 points on that rectangular coordinate plane that I just explained. So, for example, we have the point 1, 4 and 3, 2. We want to find the distance between those points. We use this beautiful formula right here. So in this case, our x2 will be the 1, 4, and our second point will be 1, 4, and our first point will be 3, 2. So we take the x from our second point, which is 1, and we subtract the x from our second point, which is 3, and then we take it and we square it. and then we add the y from our second point, which is 4, minus the y from our first point, which is 2, and we square that. And in the end, we get the square root of -2 squared plus 2 squared, which equals the square root of 8, which is equal to 2 square root of 2. So, I know I did that really fast, but you basically take the x from the first point minus the x from the second point and square it, and the y from the first point minus the y from the second point and square it, and then you take the square root of all of those and then just like work it down until you get a nice little answer. So the distance between these 2 points would be 2 square root 2 units. That's pretty much all I have for this first video. I just wanted to go over the basics. I know I wasn't clear on some of it, but like I hope you understand a little bit. If you have a trigonometry textbook with you, this would be the point to look at it. You know, maybe get some examples from in there, because it explains how to do the math and also gives you examples on how to do it and the answers and step-by-step like solutions. So I say look at that, and that's the end of our first video. Thank you so much for watching. Have a good day.